Rubyslave, ktorú sme tesne nestihli, ale podarilo sa nám zohnať dvoch speakerov, ktorí budú hovoriť o Kubernetes a Dockeri, čiže taký deployment dneska. Uvidíme, ako to dopadne. Na začiatku povinná jazda, samozrejme ďakujeme sponzorom za to, že sme tu mohli dneska, alebo že tu budeme a za to, že tu môžeme byť každý mesiac pomaly. Sme tu už 79. krát, čo je celkom teda veľa, keď si to tak prerátam na roky. A ďakujeme teda JetBrainsu za to, že nám dáva nálepky a licencie, tí, čo sledujete Rubyslavu. To je pre mňa vždy fascinujúce, že keď tam niečo napíšem, sa nič nedieje, ale keď tam rozdávam kupóny, tak do 3 sekúnd sú tam 4 príspevky. Neviem si to úplne vysvetliť, či máte nejakú špeciálnu notifikáciu na to pripravenú alebo bota. Ďakujeme Manningu za to, že nám dáva e-booky zadarmo. Ďakujeme Kiwi, že nám zaplatí takto sem tam pivo, ktoré bude až po prvej prezentácii, aby sme odfiltrovali tých, ktorí nezvládajú technické veci. A samozrejme ďakujeme ešte aj TopTavu, ktorý nám tiež sem tam zaplatí pivo. A myslím, že tuto kamaráti si to uvedú ďalej sami. A bude to po anglicky, tak dúfam, že to nikomu nevadí. A potom druhú prezentáciu asi dáme po slovensky. Uvidíme. Alebo po španielsky. Esperanto. Ďakujem všetkým, že ste prišli a už to nebudem ďalej zdržovať.
Can we do a thumbs up to take a picture of us? Mark, can you sorry? What I got?
Ako prišiel celý si održiavaš stádium.
Tak ahojte. Ako sme už povedali, bude to dneska v angličtine, lebo tu máme kolegov z USA, ale ak by ste mali nejakú otázku v slovenčine alebo tak kľudne ma zastavte a pýtajte sa.
Bližšie si daj.
Naložím. Dobre, čiže dnešná prezentácia bude o Kubernetese. Moje meno je Marek Nemec a toto je Michal Baumgartner. A teraz switchnem do tej angličtiny. Hi, I'm Mark, this is Michal, and we work for a company called Panoramic. Panoramic is a company that helps other companies connect data sources across various marketing platforms and build models to help the companies decide their next marketing strategy. Some of our famous customers are Sony Pictures, Lionsgate, Sweetgreen, and WeTransfer. I also forgot to introduce our VP of Engineering, Daniel, who's here from LA. Daniel, does that cover it?
Oh. You are a great salesman. You're doing good.
Okay. So, high-level view of what our company does. Basically, we identify the entities in your data. So this could be like a Facebook post or a YouTube video. We import data related to these entities into our platform. And then we create models, which we display in charts. So you can then use these charts to compare your marketing strategy on Facebook versus your marketing strategy on YouTube. But you can also compare your performance against industry benchmarks. So back to the talk. So I want to talk about Kubernetes and especially Kubernetes with a purpose. And what I mean by this is I want to talk about the two main points that we think are important when going with Kubernetes. The first one is getting your developers and the business to understand the value proposition of Kubernetes. And the second one being picking the right components to optimize the value effort when building your cluster. So we like to think about Kubernetes clusters as a cocktail of sorts. And like a cocktail, you can pick many different ingredients, and some of these ingredients work together better than others. And I think this is where it's important to get this right. Also, the way companies build their clusters is that everyone comes up with a slightly different cocktail, and it's kind of important to build a cocktail that looks similar to other companies. So, as I mentioned in the first point, like this talk may be for you if you work in a smallish startup that's kind of starting to scale out, which is basically our case, or you find yourself writing lots of custom deployment scripts and you kind of don't like doing it and you would like an open source software to do it for you instead because it's watched by many eyes that make sure that everything works correctly. It's ideal, I guess, if you like software that's kind of probably found elsewhere. It's not, you don't need everything to be written at your company. You don't mind pulling in third-party packages into your cluster or into your tech stack. And finally, we think this is really important. If you like declarative configuration, then Kubernetes and other tech that we talk about here is going to work quite well for you. So what I mean by declarative configuration is that you describe the desired state of your configuration, and you don't really imperatively describe how you're going to get to that desired state. Kubernetes or other services running in Kubernetes take care of that for you. So this lowers the burden on people using the cluster. So this is a slide that's meant to terrify you. It's produced by the Cloud Native Computer Foundation, and it's a landscape of all the things cloud native. So cloud native doesn't necessarily mean Kubernetes, but there's a good chance that if someone mentions cloud native, they also use Kubernetes behind the scenes. And so these are all the tools that you can pick for your cluster, and you can mix and match across this whole landscape. And this is what I meant by, making a cocktail. You need to pick some tools in here, ideally, and you want to get those tools right because they'll be really important for your processes. Cool. So moving on, we're gonna now talk about our story of how we picked Kubernetes, why we picked Kubernetes, what choices we made along the way. So this includes the tools, and where we are now, and what we're looking at next as a company. So around 1 year ago, our main user-facing application was running in Heroku. It actually still runs in Heroku right now because we haven't found the need to move it to Kubernetes. We wrote everything in Docker, so Docker files for everything, running everything as a container, deploying containers to AWS Fargate, which is a serverless platform from AWS. So the way Fargate works is you kind of describe your jobs or your applications as tasks, and you assign them a Docker image, a command that you want to run on that Docker image, and then possibly the number of tasks that you want to spin up, so you can have like several replicas of one task running. We also had some stuff running in Heroku, which is kind of like based on the fact that initially everything was in Heroku. And so we used like a custom cron add-on for Heroku. We also used AWS Lambda for a few things. And so the deployment of this was kind of like heavily leaning on Heroku for the Heroku parts, and using Terraform via Jenkins for everything that was running in AWS. So Terraform is a great tool. If you haven't used it, it basically allows you to describe your AWS resources in a language called HCL. And the way it works is you write your file, you run a Terraform plan. Terraform will tell you what it's going to change in AWS for you, and then you can approve or abort that plan and not run it. So it'll only make the changes that you kind of like pick out. And so one problem we had with Terraform was that it was really good at doing this stuff of deploying infrastructure to AWS, but it wasn't that great for deploying things, and the reason for that is you couldn't do like rolling updates, so you couldn't scale down your existing application, scale out your scale down the existing version of your application, and then scale out the new version of your application kind of at the same time. Like you could make it work, but it doesn't work natively. And then I would like to highlight this, like, because basically what it all comes down to is the process. The process of how you develop software, process of how you deploy software. And for us, we like to encourage developers to write their infrastructure code. They would do this in Terraform. And for any kind of service that was similar to a service that they have written before, there would be a lot of kind of like copy pasting and tweaking a few things here and there, right? And for anything new that they would be writing, they would lean on the infrastructure team. So the infrastructure team could often become the bottleneck for the whole process because they were a big dependency for everyone. So they were kind of sitting in the middle, and everyone required their help. And the other thing I already mentioned, so we had some peculiarities in how we deploy software. Every service, well, not every service, but some services work differently than others. And when you were working on a certain service, you kind of had to remember how it's deployed, and probably you forgot something. Maybe there was even a service that only a few people could deploy, that kind of thing. And then, very importantly, secrets, so database passwords, that kind of thing. We found as we were moving to Kubernetes that we weren't handling them with the respect they deserve. They weren't centralized in one place where everyone could edit the secrets that belong to their team, but not be able to see secrets that belong to other teams. Does that sound about right?
Luckily, it's my only slide, so I'm going to disappear immediately. I'm playing the role of a business manager at this point. Mark came to me and asked, like, so can I have this thing to play with? I'm like, can you explain to me what this gives to the business? And he actually did, right there. Majority of the values he kind of explained is fundamentally important to the business. You have to run fast, and fast means not just him running fast or deploying fast. It's actually allowing someone like Michal to deploy data science tasks in a whim without almost hindrance. When you have to depend on DevOps, SRE, development team to get your stuff out, you don't run fast. We do, right? So what does it take to be operational efficient? I hope Mark explains what I mean by operational efficient. I'm sorry, I speak business language, he'll probably explain in a better way. But what we realize is that really we have to have three things, fundamentally important things to explain to business as to why you're doing this. Number one, is it going to decrease your costs, right? Number two, how is it going to help our teammates to get things done easily? How do you get yourself out of the way? And number three, how do you remove the secrets from the repos into the proper place, right? Because at one point I had almost a heart attack when I saw a secret, a password in the repository in GitHub, and that was the last draw. Like this should not happen. Compliance goes out of the window when you have this scenario. You have to be really brutal and kind of very clinical and simple about why you do this stuff. There are many reasons why you want to have a Kubernetes cluster. You have to choose 2 or 3, otherwise you're going to be distracted. Mark kind of went for the fundamental one, cost. We were running on Fargate. Fargate costs about 3 times more than a spot instance on AWS. How do you make spot instances painless? How do you make them show up and disappear without you noticing? You have to have an abstraction layer, Kubernetes. That was the first feather in his cap. He's like, yeah, I'm going to abstract the cost for you. It's going to make it manageable through the ASG, which is the simplest possible way to bring spot instances in without your tasks really kind of caring to if your instance is going to go away. Number 2, how are you going to help operational efficiency or someone like Michal? The goal for us was to kind of give him tools within a certain domain. How do you virtualize the domain to which you can give the rights to? Kubernetes, again, it's an abstraction layer over real hardware. It's a way for you to say, I manage hardware, you manage this space. So he basically, like, this is the requirement for going this way. The final one is the secrets, and we went back and forth. We were addicted to SSMs, which is AWS technology for storing secrets at the time. And it was annoying to manage the permissions for them, rights management and so on. And again, Mark came in and basically suggested we do this. When you focus the OKR, the KPI, the reason for doing something as an engineer, give them the power to do so, comes out amazing stuff. So, back to you.
Cool. So actually, it's back to Michal now. Well, Michal is working in our data science team, and he'll explain what was happening in data science at this point.
Great, thank you. So most of this talk was from the operations perspective, and we're going to talk about being sort of the customer for the whole Kubernetes setup. Sort of to give you some background, prior to migrating to Kubernetes, we were running on Heroku, as rest of the company did, so followed the way. We pushed the containers to Heroku upon builds, so we build our images on CircleCI, push them to the Heroku container registry, and then used certain add-ons to schedule jobs and pick the dyno sizes, which was not a pleasant experience, but it wasn't the worst. We often ran into problems where we had a lot of cron jobs that were turned on and you were kind of afraid to delete it or change something because we didn't know to whom it belonged. And we also used some like off-the-shelf one-click install stuff for logging and running Redis, which has proven to be not ideal. And then the second use case we had were Flask applications, or basically random stuff spread over the AWS landscape. And it got to a point where security and compliance had to be set in place. So there was a strong push from the infrastructure team to kind of templatize all of this into Terraform, so the data science team could just spin up a new repo and have everything already prepared. But then if you wanted to make small changes, you would sort of have to say like, Tom, I need to add in a celery queue, can you help me adjust the Terraform script because I have no idea how that stuff works. And then when Tom was busy, he was like, Mark, can you help us change this? And since the bottleneck was also the engineering team, the data science had to wait because the turnaround was pretty long, but we wanted to iterate fast. So this all turned out to be a very tricky experience with managing all the secrets that were in Heroku, some other places, Terraform, and then we had various CI setups and Docker files written for us by other people, which we weren't really familiar with. So we kind of jumped on this Kubernetes train to sort of make it easier for us to do our job rather than fighting Terraform and similar tools. And goes back to Mark, who helped us spin all that up.
Yeah, so the first thing that actually, the first thing that we decided to migrate to Kubernetes to kind of like try out Kubernetes for was actually the data science jobs running in Heroku. And so our requirements were, we wanted to run many jobs concurrently on a custom schedule. We wanted to utilize the servers as much as we could. So ideally, if you have a job that needs a lot of memory and you have a job that needs a lot of CPU, you kind of put them together to maximize the usage of a server. And then, ideally deployment would be super simple. So with cron jobs specifically, there's no like, they don't run immediately after you deploy them, so they're kind of like simple to work with. And then, there were some benefits for the business when starting out with these jobs, because they were sort of like low risk area of the pipeline. So if Kubernetes didn't work out at all, we could just throw out Kubernetes and go back to where we were. They offered significant, we basically could get significant cost savings. So as Daniel mentioned, you can save a lot of money if you switch to EC2 spot instances, which can be 4 times cheaper than Fargate, which is the serverless platform. And to compare it to Heroku, one performance dyno, which is like a beefier version of a virtual server in Heroku, is $250 a month. So these things don't run for like a full month, so it wasn't that much money, but you can sort of imagine that EC2 on AWS is cheaper. Cool. So this is kind of what we were going for, right? Like really simple. You just have a list of jobs, then you have a schedule of when you want to run them. When they were last scheduled, then you can kind of trigger them from here. Super simple. So, I mean, the experiment worked out, right? Over time, it showed to be a kind of like a good starting point for us. But even when you start with Kubernetes, you can start with an empty cluster that doesn't have anything in it, but you're gonna struggle. So these are the kind of tools that we relied on the most. So I'll go over most of them, I think, and we'll briefly talk about what they do and like why they were good fit for us. So the first one is how do you even get a Kubernetes cluster? So we use AWS. We're an AWS shop, but we try to stay cloud agnostic when we can. So that's why we picked Terraform, which I already mentioned, to kind of like provision our cluster. So it has support for the Kubernetes cluster. The resolution on this projector isn't great, so you can't see it, but I swear in the top right that's kind of like what you need to write in HCL to get a cluster running. And then you run the plan, and then on the bottom right you can approve or abort if you don't want to create the cluster. So Terraform is nice as well because it does idempotent updates. So as I mentioned, it's declarative, so it figures out what you need to change, and it's up to you whether you want to apply the plan or not. And then we went with Terraform because it also ties in with the rest of our infrastructure. So we could easily hook in our EC2 spot instances to kind of save some money. And we could link it to our existing VPC and subnet resources that were already defined in Terraform. So it kind of like hooked into that nicely. So like VPC and subnets and security groups kind of configure who has access to your cluster and that kind of thing. So if you haven't worked much with Kubernetes, then all of this might have seemed kind of like very abstract. So I'll kind of want to go over like an example Kubernetes workload. So basically, to get a cron job running in Kubernetes, all you need to do is write a YAML file that's about 30 lines long. And then hopefully you can see it, but what we do in this YAML file is we say what Docker image we want to run, what's the command that we want to execute on this Docker image, and then we describe the resources that our job is going to be using. So in this case, it's like 1 CPU and 1 gig of memory. And then at the top there's the schedule, which describes how often this job runs. So you kind of submit this file to the cluster by just running kubectl apply file, and then Kubernetes takes care to run this job every hour as you defined. We decided that every project gets its own namespace within Kubernetes. So namespace is like namespaces in other software stacks. It's a grouping of workloads. And this works well because it reduces blast radius. So if you have a workload that's misbehaving, you can configure it so that it only affects its own namespace and doesn't bring down the whole cluster. And then also this is good for compliance because if you need to comply with some laws, you can set it up so that certain teams only see certain namespaces and they don't mess with each other's stuff. And then Kubernetes also has rolling updates built in, which isn't necessarily useful for cron jobs. But once you start putting web applications into Kubernetes, that's kind of neat because you can slowly scale out your new version and then slowly scale down the old version, and you can configure how quickly you want to do it and what strategy you want to use, that kind of thing. And the EKS product from Amazon integrates well with IAM. So if you already use IAM to access DynamoDB or other AWS services, you can hook that into Kubernetes and then define that your job has access to these tables and nothing else will have access to them. Okay, so now that you know what a Kubernetes workload looks like, you quickly realize that even if you only have like 10 jobs, and that one was a really silly example of like 30 lines, but assuming like 100 lines of YAML per job, you quickly get to like thousands of lines of YAML. And writing all this YAML can get pretty boring and annoying because there's a lot of duplication. Like a lot of the stuff that you have to write is shared across all your workloads. So this is where Customize, which is now integrated even into the official Kubernetes tool called kubectl. Comes in handy because you can define a base. And what a base is like a common definition of, let's say, a cron job. And then you define overlays, and your overlays can be specific to, let's say, job X needs this Docker image and runs this command, and then job Y needs another image and runs a different command, right? And so you only need these tiny files to kind of like override what's in the base. So it really accelerates development of new infrastructure. I think Michal will talk about this, but basically, you only need to write the base once, and then as you add more and more stuff into it, you only produce these tiny batch files. So that's how it avoids the copy-paste problem of having thousands of lines of YAML. Another cool thing you can do using Kustomize is automatically inject how you're gonna bring secrets and configuration if you store that somewhere else. How you're going to bring that into your workloads. So we use HashiCorp Vault, which is a secret store, and HashiCorp Console, which is used for configuration. So you can write secrets and configuration in these services, and then they're injected into your job or your application. So briefly about these two tools, they're open source software from HashiCorp, same as Terraform. You can probably tell we like HashiCorp. And the reason that developers like these tools is because they have a nice user experience. It works like a file system. And that's also why operators or like DevOps people like me like them, is because I can set up rules in an ACL language where Team X can see the DB passwords to Project 9, but Team Y doesn't see that, right? And you can set this up like in a dynamic way. And so that's why business likes this as well, is they're good for compliance, so you can prove that like people can't see random stuff that they shouldn't see. And like I mentioned, they're auto-injected into containers, so the containers don't even need to be aware of these things existing. They kind of start up, and the secrets are already there together with the configuration using a thing called init containers in Kubernetes. And this thing here is my favorite part of our setup. So maybe you haven't heard of GitOps, but if you have heard of GitOps, you've definitely heard of Flux. So Flux is like the first GitOps tool that I know. And the reason Flux and GitOps in general is nice is when you write all of this YAML and like customized patches, it works in a declarative way, right? Like you apply it against the cluster, but how do you know that like the YAML you've written is what's running in the cluster? So this is where Flux comes in. You create the Git repository, you put all your YAML into the Git repository, and then you point Flux at the Git repository and at your cluster, and it automatically syncs anything that's in the repository with your cluster. So it runs in like a polling way, and it will git clone the repo and then apply it against the cluster. So this is super powerful because if there is an incident and your whole cluster running in AWS explodes, it doesn't really matter because you bring up a new cluster. Well, it does matter, but it doesn't matter as much. You bring up a new cluster, you put Flux in it, you point it at the Git repository, and in minutes you're back where you were. You have the same cluster that you were running a while ago. So like this is what I mentioned with declarative configuration. It's super nice for this. And yeah, it works for me because everything that goes into the cluster goes through a pull request approval on GitHub. So people supply YAML files and I get to approve them. And then it also works for developers because they can look at the repo, see what other people have built, and build on top of that. And it works with Kustomize, so you don't have to worry about having like generated YAML in your repository. You can just do the thing that I mentioned where you don't repeat yourself too much. And it also garbage collects the resources that you've deleted from the repository from the cluster. So it does like a full-on sync. It doesn't just add new stuff. It also deletes the stuff that you removed from the repo. So in short, this is kind of how it works. Basically, when a new commit into the repo comes in, Flux will notice, sync it with the Kubernetes API, and Kubernetes API behind the scenes uses etc3. But if you use a managed Kubernetes, you don't need to know that. The other super cool thing that Flux does is